These are the Math 205 group activities for lesson number 2. Okay, we want to set up an augmented system for the system and say what its dimensions are. Okay, so to do an augmented matrix, we put the x1 coefficients in the first column. So this first equation, its x1 coefficient is a 1. The next equation has no x1 term, so its coefficient is 0. The next equation, the x1 coefficient is a 2. And in the last equation, there is no x1 term, so the coefficient is 0 again. Then I do the x2 coefficients in column 2, so that's going to be 1, 1, 2, negative 3. 1, 1, 2, negative 3. And then the x3 coefficients in the third column, so that's going to be negative 1, 2, negative 1, negative 6. And then the x4 coefficients in the fourth column, so that's 0, 6, 0, negative 18. And then I'm going to augment. They put a vertical line there for the augmentation. And on the after that, I'm going to put what each equation equals. The constants all go on the right. So this is going to be 0, 1, 2, 2. So that's my augmented matrix, and it has 1, 2, 3, 4 rows by 1, 2, 3, 4, 5 columns. So its dimensions are 4 by 5, 4 rows, 5 columns. The next several questions are going to walk us through the algorithm for solving this system using row operations on an augmented matrix. So our first goal is to use row 1 to eliminate all entries in the first column that are below row 1. So I want to use row 1 to eliminate all entries in the first column below row 1. So I'm going to use this one to eliminate every entry, this one and this one and this one. Okay. I should be able to accomplish this with just one step because I already have zeros here and here. So I just need to eliminate this 2. I want to make that into a 0. So the only row that should be changing is row 3. Okay, so row 3 is going to become row 3 plus, and then I'm going to use a multiple of row 1. So I want to use row 1 to get rid of row 3. So you take row 3 and add to it a multiple of row 1. So if I add negative 2 row 1, that will make the 2 go away. Okay, so I'm going to write out my work here. So row 3 plus negative 2 row 1. Okay, so row 3 is 2, 2, negative 1, 0, 2. Do that right? Let me double check. 2, 2, negative 1, 0, 2. That's row 3. And negative 2 times row 1 is going to give me negative 2, negative 2, 2, 0, 0. So when I add them, my new row 3 is going to be 0, 0, 1, 0, 2. Okay, so my new matrix is going to be exactly my old matrix. The only thing that's changing is I'm going to replace row 3 with a new row 3. Everything else just gets copied. So I have 1, 1, negative 1, 0, 0. Okay, row 2 just gets copied, and that is 0, 1, 2, 6, 1. 0, 1, 2, 6, 1. Augment there. New row 3, 0, 0, 1, 0, 2. And then row 4 just gets copied from earlier. That is 0, negative 3, negative 6, negative 18, 2. Okay, so my first goal is accomplished in that my first column has a 1 in the first entry and zeros below it. Okay, so I used row 1 to eliminate all the entries in the first column below the first row. Okay, so next we want to look at column 2. So I'm going to grab that matrix and put it on this page. Okay, so I have my previous matrix from my last step. Now I want to look at column 2. Okay, so I dealt with column 1 well. I have zeros in all the entries below the first entry. Okay, so now I want all the entries in column 2 that are below row 2 to be 0. So here's row 2. I want everything underneath this 1 to be a 0. So that's already a 0. I need this to be a 0. So I'm going to change row 4. Okay, so my step is that I want to replace row 4 with row 4 plus a multiple of row 2. Right? It says to use row 2. All the entries in column 2 that are below row 2 to be 0. So use row 2 to eliminate it. So I'm going to do row 4 plus 3 row 2. Because 3 times 1 would be 3, and when I add them together, I'll get 0. So let's see, I'll write out my work here. Row 4 plus 3 row 2. That's going to give me my new row 4. Okay, so row 4 is 0, -3, -6, -18, 2. 3 times row 2 is 0, 3, 6. So multiplying by 3 here. 6 times 3 is 18, and 1 times 3 is 3. When I add them, I get 0, 0, 0, 0, 5. So that's my new row 4. So my next matrix, row equivalent matrix, all of my rows stay exactly the same except for row 4. Row 4 becomes 0, 0, 0, 0, 5. Every other row is just going to get copied from the previous step. So 0, 0, 1, 0, 2, and 0, 1, 2, 6, 1, and 1, 1, -1, 0, 0. Okay, so our matrix is now in triangular form. So what happens if we translate this matrix back to a system of equations and try to back substitute and finish solving? So I'm going to do that right next to this matrix. So this first row, this says x1 plus x2 minus x3 equals 0. So these are the coefficients on x1, x2, x3, x4. The vertical line is equals, and then the final column is the constants. X4, okay. So my next row says 0x1, so just x2 plus 2x3 plus 6x4 equals 1. And my third row says x3 equals 2. And my last row says 0x1 plus 0x2 plus 0x3 plus 0x4 equals 5. And that is impossible because this says 0 equals 5. So it turns out that this is called an inconsistent system. A system of equations with no solutions is called inconsistent. And the one we just obtained where we got 0 equals a number, that is typical of an inconsistent system in triangular form. All right, let's look at this augmented matrix. We want to add the missing vertical line to the above matrix. So if this is an augmented matrix, then it's the last column, that's the constants. So we add the vertical line before the last column. What system of linear equations is represented by the matrix? x1 minus 2x2 equals -3, and -2x1 plus 4x2 equals 6. What row operations should be done next to put this matrix into triangular form? So you work column by column from left to right. So I want to work on the first column, and I want everything below the first row to be a 0. So I want that -2 to be a 0. So I'm going to make a new row 2, transform row 2, replace it with itself plus a multiple of row 1. So I would add 2 row 1 to it. And I'm going to get, only row 2 is changing, so I'm just going to copy row 1. Okay, row 2 is going to be itself plus 2 row 1. So -2 plus 2 is 0. 4 plus -4 is 0. And 6 minus plus -6 is 0. So what do we think that this indicates? So if I translate this back to equations, this says x1 minus 2x2 equals -3, and 0x1 plus 0x2 equals 0. This is not impossible, not a contradiction like it was before, right? What made it a contradiction before is that this number was not 0, so I got 0 equals a number. Now I have 0 equals 0. That's totally fine, right? That's true. So what I have here is infinite solutions. Any x1 and x2 that satisfies this first equation is a solution. Okay, here's an augmented matrix. 2, -3, h, -6, 9, 5. Add the vertical line. What system of linear equations is represented by the matrix? This says 2x1 minus 3x2 equals h, and -6x1 plus 9x2 equals 5. What row operation should be done next to put the matrix into triangular form? I need that to be a 0. I want to use row 1 to eliminate everything in column 1 below row 1. So I'm going to replace row 2 with row 2 plus a multiple of row 1. So I would multiply row 1 by 3 to make that go away. Okay, so my new matrix, row 1's not changing, 2, -3, h. My row 2 is going to be row 2 plus 3 row 1. So -6 plus 3 times 2 is 0. And then 9 plus 3 times -3 is 0. And 5 plus 3 times h. 5 plus 3h. Goes in the last entry there. So what values of h will make the system I wrote consistent? So because I have 0, 0 here, the only way this system is consistent is if 5 plus 3h is 0. If 5 plus 3h were not 0, I would have 0 equals a number, which is impossible, and we would have an inconsistent system. So it has to be that 5 plus 3h equals 0 to get a consistent system. And then I solve for h. So h is -5 thirds. Okay, we've got one last problem. We're going to pull this all together. I have a system, 3 equations, 3 unknowns, and I'm going to solve it using row operations. So I'm going to start by translating this to an augmented matrix. So my x coefficients are 1, 2, 0. My y coefficients are 0, 2, 1. And my z coefficients are -3, 9, 5. Augment with the right-hand side of the equation, 8, 7, -2. So I work left to right, column by column. So when I'm working on column 1, my goal is to eliminate every entry below row 1. So I want that to be a 0 and that to be a 0. So This one's already a 0, so that's good. So to make this 2 into a 0, I'm going to do row 2 needs to be replaced, and it's going to be replaced with itself plus a multiple of row 1. So I'm going to use -2 row 1 to replace it. And I'm going to end up with a row equivalent matrix. The only thing that's changing is row 2. So to remind myself of that, I like to copy the other rows before I start trying to do my replacement. Okay, so row 2 is changing. Row 2 is going to become itself plus -2 row 1. So I'm doing -2 times this first row and adding to row 2. So 2 plus -2 is 0. And then 2 plus 0 is 2. And 9 plus 6 is 15. And 7 minus 16 is -9. So row 1 is set. I have zeros in the first column. So column 1 is set, sorry. Column 1 is set. I have zeros underneath row 1. So now I'm going to work on column 2. Working on column 2. The goal is to have zeros underneath row 2. So I need that to be a 0. Sometimes it's helpful to scale a row to do this. So I think I'm going to scale row 2 before I move on. I'm going to make row 2 1/2 of row 2. It's always helpful to have the pivot you're working on be a 1. So my next row equivalent matrix, I'm only changing row 2, so I'm going to copy my other 2 rows first. And then I'm going to scale row 2 by 1/2. So I'm going to get 0, 1. 1/2 of 15 is 7.5. And 1/2 of -9 is -4.5. Okay, so now, still working on column 2, I want the entry under row 2 to be a 0. So I'm looking to make everything under the main diagonal, which is this entry, and this entry. Everything under that main diagonal needs to be a 0. So I just need to make that one a 0. That's row 3 that I'm changing. So row 3 is going to become row 3 plus a multiple of row 2. So when you're working on column 2, you always use row 2 to knock out the elements that you want to knock out. So I'm going to do negative row 2. And I'm going to get a row equivalent matrix. Everything stays the same except for row 3. So I'm going to copy rows 1 and 2 before I even start doing work here. And then my third row is going to be row 3 plus negative row 2. So 0 plus 0 is 0. Okay. 1 plus -1 is 0. 5 plus -7.5 is -2.5. And -2 minus -4.5, that's -2 plus 4.5, which is 2.5. Okay, so this should be enough to solve the system. I'm going to do one last thing, and I'm going to scale the third row. I'm going to have row 3 become 1 over 2.5, negative 1 over 2.5 times row 3, so that this entry will be a 1. Really helpful to have 1s along your main diagonal. So my new row equivalent matrix, my first 2 rows don't change. And my third row, I'm scaling by 1 over 2.5, negative. So this becomes 0, 0, 1, negative 1. At this point, I have solved for z. The last row says that z equals negative 1. 1z equals negative 1. My second row says that y plus 7.5z equals negative 4.5. And I know what z is, which means that I can back substitute to get y. So this says y minus 7.5 equals negative 4.5. Add 7.5 to both sides, and you get y equals 3. And then my first row, this says x minus 3z equals 8. And I know what z is. Z is negative 1. So this says x plus 3 equals 8 plus 3 because it's negative 3 times negative 1. So that means that x equals 5.